We saved example number 1 because I'm going to call this question a special name. This is on, double triangle question. It is on page 637. I'm going to call it a double triangle question because you have to draw 2 triangles to solve it. And upon reading it, it sounds like one of the scariest questions we've had so far. You read it, given angle alpha is in standard position with its terminal arm in quadrant 3, cos alpha is 3/5, and beta's in quadrant 2, and sine beta is 1/3. Find sine alpha plus beta. It just seems like a lot of stuff. Alpha and beta are Greek.
So no, it's technically not.
But it actually is a very, if you recognize something as a double triangle question, it's really easy to solve. Because what you need to do is you need to draw your triangle for alpha in the correct quadrant. And it tells us that alpha is in quadrant 3, so we can make a triangle with the reference angle for alpha in quadrant 3. And because we know cos of alpha is 3/5, we know the adjacent side is 3, the hypotenuse is 5. That's our first triangle. Our second triangle is going to be our beta triangle. Beta is in quadrant 2. So we can draw a triangle back to the nearest x-axis so we can label our reference angle for beta. And because we know sine of beta is 1/3, we can label opposite over hypotenuse as 1/3. I'm going to leave a little bit of space beside my triangles and say the question is asking us to find the exact value of sine alpha plus beta. And on our formula sheet, we have a formula for alpha plus beta with sine. It's equal to sine alpha sine beta. No, sorry. It's equal to sine alpha cos beta plus cos alpha sine beta. How do our triangles and why do we draw double angle triangles? Well, from our alpha triangle, can you see that a squared plus b squared equals c squared? You could solve for this side to find out that it's 4. And this one, a squared plus b squared equals c squared, find out that this side will be the square root of 8. And so from our first triangle, we already knew that cos of alpha was -3/5, but now we know sine of alpha is 4/5, and it will be positive because it's in quadrant 2. And from our second triangle, we already knew that sine of beta was -1/3, but now we know that cos of beta is -8. √8/3. And so because we figured out each of those, we can now plug things into what we want to find here. Now what's going to happen next is I'm going to do a survey. I do this survey every year because what you write next, the answers are all right there. Despite that, what we write next, I've noticed about 50% of the class makes a common mistake and 50% of the class does it right the first time. If I don't point out the common mistake now, you will do it on your quiz and your test. But if you make the mistake now, so that's why I want you to write the next line on your own. If you make the mistake now and I point it out, then you can really focus on that and try to remember, I don't want to make that mistake again. The question is, when we substitute in here, do we know what alpha is? Or do we know what sine of alpha is? We know what sine of alpha is. So that means all of sine of alpha gets replaced with 4/5. We don't know what alpha is. We know all of sine of alpha. We know all of cos of beta is -√8/3. We know all of cos alpha is negative 3 over 5. And we know all of sine of beta is negative 1 over 3.
Why is it negative 1 over 3? It should be positive.
Was it? Oh, yeah, sorry, it was positive here, and it's positive here. Thank you. And so now we're going to get negative 4 root 8 over 15 minus 3 over 15. In math, we always write our final answer as a single fraction. And that is the exact value. You don't need to simplify the root 8, even though you could, to be 2 root 2. You would leave your answer like that.
So why didn't we keep the sine and cos? Just because that's the value.
Well, in order to keep the sine and the cos, you would need to know what alpha is. Is 4/5 on our pie plate? No. And these are always non-calculator questions. So we can't figure out what alpha is without our calculator. But we do know what sine of alpha is. And the question never asked us to find alpha or to find beta. It asked us to find the exact value of sine alpha plus beta. So the substitution thing is when you're substituting something in, you have to ask yourself, what I'm substituting in, do I know that value? Did I know what alpha was? No. But I did know what all of sine alpha was, so I could replace all of sine alpha with 4/5. All right, question 8 and 13.